Hey guys, welcome to the sixth episode in the series Artificial Intelligence. In this episode, we will look at how we can create artificial general intelligence. This episode will be the building block on the previous episodes where we discussed the uses of AI, levels of AI, and other things. If you have not watched them, I will have the links in the description below. All of the AI that we have developed so far are experts in one task alone. This is artificial narrow intelligence. But how can we get to the next level? Artificial general intelligence. We are exploring largest things known to man using astronomy and the smallest things using theoretical physics. But we are still unable to decipher how the brain functions, let alone recreate it and with such efficiency. AGI is where the computer can perform every task, including thinking, as good as humans can. Here are the 8 ways in which we can try to do just that. 8th one is my favorite. Reconstructing the human brain using transistors. In this method, we will try to deconstruct the human brain first and replicate all of its neurons using transistors. These transistors are in circuits which can weaken or strengthen based on feedback. Our brain is bowling ball size and just takes the energy of an iPad. However, if we are trying to replicate the brain and all of its neurons as transistors, it might be the size of a data center and can take the electricity of a whole city. As this machine tries to learn from data, it will try to replicate how humans function. It may have the inefficiencies that we do, but it will be wired to value what we value. The second way is similar to the first one, but instead of using the transistors for neurons, we will use software code to replicate the neurons and the connections between them. Such AI will have the flexibility of modifying itself without any hardware restrictions. It will cost a lot less and can function on existing hardware. But in these two methods, we have to be careful whose brain we are trying to emulate. That person, if they have good intentions, it will be good for all of us. But who will decide whose brain to replicate? Will it be the president? Do we get to vote on it? Maybe it is better to replicate the brain of a human baby to start with. The third way is to give brain data to AI and then build AGI. Current AI algorithms are very good at recognizing patterns. We can give fMRI data and whole brain scan images so that the AI can learn how the brain functions on its own. Using this method, we can identify the patterns and also what we value as a human species. This can help us to come up with better rules of designing AGI. The fourth method using which we can create artificial brain is evolution. Humans evolved from single-celled organisms in the primordial soup. That process took a few billion years. If we can replicate the same process using the DNA as the input for a program and ask it to replicate itself over and over again and become more and more intelligent, we probably will have an intelligent being. You might ask, won't it take billions of years? No, because we as biological beings are limited to the supply of energy that we have, and also we improve with trial and error. Not only that, the improvement in intelligence only happens through reproduction. In humans, it takes about 15 to 20 years. However, AGI revolution in the software environment can take 15 to 20 milliseconds. This may be feasible, but the AGI which evolved in a software environment will not have the same values that we have. It may not develop emotions at all because it may not need them to survive. Think of what would happen if such an AI takes control of humans. The fifth method of creating AGI is to outsource the task to the algorithms itself. If we program the algorithms to improve their intelligence over time by doing AI research, modifying their code, and also the architecture, then it will probably end up being smarter and eventually as smart as us. The sixth way in which we can create AGI is machine biology hybrids. To do this, we initially start with connecting our brains to the internet, and we reap all the benefits of this interface for a few years. Elon Musk's Neuralink is trying to do the same thing. We have 3 layers in our brain, and the topmost layer is called the neocortex. Neocortex is where all the intelligence happens. When we connect our brain to the internet can function as the 4th layer on top of neocortex. As we progress through time, all the data that the computers can collect that is coming out of our brain in this interface can be used to identify patterns and also figure out how our brain actually works. Once we have enough data, the computers can create an algorithm that functions just like we do. The 7th way in which we can achieve AGI is to join several artificial narrow intelligence modules. Google is trying to do the same. They're developing ANI in several fields such as autonomous driving, medicine, and others. These ANI modules will have everything that a human can do, including music, scientific research, and art. This method believes that once we join all these narrow intelligences intricately, it will become AGI. But will this be AGI? What do you think? Leave your comment below. The 8th method, which is my favorite, is replicating hierarchical modular design of neocortex. Let me explain what this actually is. According to Ray Kurzweil, who is a leading thinker in AI, our neocortex is made of 300 million modules. These modules have 100 neurons each, and these modules are arranged in a hierarchical fashion. The modules lower in this hierarchy are responsible for tasks such as identifying that this is a straight line. The higher we go, the modules are the same, but the data that they process increase in complexity. The modules at the top of this hierarchy are responsible for things such as music, language, thinking, and others. If we can write the software for one module, we will be able to replicate it for 300 million times, which is feasible given the data centers and the computational power we have right now. The next step is to design the algorithm that actually manages the hierarchy and the resources allocated to each of these modules. This method claims that this hierarchical modular method of replicating the neocortex will be able to produce artificial general intelligence. In summary, first 2 methods require to decipher the brain and replicate it using hardware or software. The third method is to use the brain scans and MRIs so that the software and the algorithms will figure out how the brain functions, and then we can create AGI. Fourth method involves evolution of the software from a single cell into an intelligent being. The 5th method is to outsource this process to machines themselves. The machines will develop the algorithms on their own by researching and also by modifying their algorithms and architecture. The 6th one is to connect our brains to the internet and let the ANI figure out the patterns in which we think and our brain functions. Based on this, we create AGI. The 7th method is to join several ANIs and expect them to be AGI. The 8th method is designing our neocortex using the modules arranged in a hierarchy. Which of these methods do you think will result in an AGI? If any one of them can do it, will it be a good AGI? In the next episodes, we will discuss about sentience, superintelligence, and the future of humanity. Stay tuned by subscribing. Thank you and have a great day as always.